Okay, in this video we're going to talk about the side angle side postulate. It's another postulate, so you can't prove it. Okay, it's something that we assume to be true. And basically it says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So we have to talk about what it means to be included. Well, here angle A is the included angle because it's between side AB and AC. So since segment AB matches segment EF, since the angle A, which is included between the two sides, matches angle E, and since segment AC matches segment ED, we can use the side angle side congruence postulate, which means the two triangles are congruent. Again, the reason why side angle side and side 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 are useful is because they prevent us from having to show all corresponding sides and all corresponding angles. So in a way, they're kind of like a shortcut. They let us bypass all that work in order to more quickly show that two triangles are congruent. Okay, let's go ahead and use side angle side to explain why triangle ABC is congruent to triangle DBC. Well, we know immediately from the beginning here that AB is congruent to DB. AB is congruent to DB. You can actually see that in the way the letters are arranged in the triangle. We know that angle CBD is congruent to angle CBA. Both of these angles are intended angles, meaning this angle here, CBD, is between BC and BD, so it's intended. So these angles are congruent. Lastly, AB is congruent to DB, and BC is congruent to itself by the reflexive property. So the way that we would organize this is we would say, hey, since BD is congruent to BA, that's the first part, angle ABC is congruent to angle DBC, and finally, BC is congruent to itself by the reflexive property. So by the side angle side postulate, the two triangles are congruent. Okay, here we want to show that triangle DEF is congruent to JGF for the value of y is equal to 7. So what's our first step? The very first thing we do is we plug 7 into JG. So by plugging 7 in, we get 2 times 7 plus 1. And when we do that, we get the number 15. The next thing we do is we plug 7 in for GH, and when we do that, 7 squared minus 4 times 7 plus 3, we get the number 24. So GH is 24. Lastly, what we do is we plug in 7 for angle G, 2 times 7 plus 42, and we get 126 degrees. Now we match them up letter for letter in the original given right here. We know that DE matches JG, and so when I have DE and JG, I get 15. EF matches GH, so here's EF, and that matches GH, and they're both equal to 24. And then finally, plugging in the corresponding intended angles, I get 126 is congruent to 126. So since the sides are congruent and the intended angle is congruent, I know that the two triangles are congruent by side angle side. Okay, so let's actually use what we've been learning now. What we're given here is we want to prove that triangle EGF is congruent to triangle HFG. We're given that line L is parallel with line M. So all of our postulates and theorems that involve parallel lines and transversals apply here. We're also given that EG is congruent to HF. So we know that this segment is congruent to this one. So what's our plan of attack? Well, the first thing we're going to do is we're just going to say that segment GF is congruent to GF, because that is the side that links the two triangles together. And we can do that by the reflexive property. So GF is congruent to GF. The last thing that we can do here is we're going to tackle the angle that's intended between EG and GF, and also the angle that's intended between GF and FH. Remember, intended simply means the angle between the two given sides. Well, I know therefore that angle EGF is congruent to angle HFG because line L is parallel to line M, and by the alternate interior angle theorem, I know that those two angles are congruent. So angle EGF is congruent to angle HFG. Well, now I have side angle side. Two sides of the triangle and their intended angles are correspondingly congruent. So by side angle side, triangle EGF is congruent to triangle HFG.